So in friction, next topic, we are going to see how to derive the expression for acceleration of your body. How to derive the expression for acceleration of your body sliding down on smooth inclined plane. So in the same way, moving up or projected up. Moving up or projected up. For this also we have to derive acceleration of your body in the smooth inclined plane. The next one we are going to see is the same accelerations of your body sliding down and moving up on a rough inclined plane. So we are going to see 4 parts here. Number 1, sliding down. Number 2, moving up. Sliding down and moving up in smooth inclined plane. 2 parts are there. Same sliding down and moving up in the rough inclined plane. Again 2 parts. Totally 4 parts are there. So listen carefully. Very easy only. Here, the first one, you see the diagram. From the inclined plane, we know if m is the mass of the body, mg is the weight which acts vertically downwards. If theta is the angle of inclination, the same theta here also it forms here. So the mg is divided, that means resolved into 2 components, mg cos theta and mg sin theta. So from the diagram we can write R is equal to mg cos theta. R is equal to mg cos theta. And also from the diagram Fs is equal to mg sin theta. It is applicable only in the equilibrium position. R is balanced by mg cos theta, frictional force is balanced by mg sin theta. Suppose if theta increases little bit, what happens? In turn mg sin theta increases and also the frictional force of static friction increases to a particular value only. Maximum value only. Maximum value of static friction, it is called limiting friction. If it exceeds the value of limiting friction, the body will slide down. For smooth inclined plane, if it is smooth, friction will be there, but it will be less. So we are not taking the frictional force into account. So from this diagram, which is the net downward force for the downward action, for moving downward, for sliding downward, which is the net downward force? So from the diagram, the Fs is equal to mg theta is the net downward force. Because of that force only it slides down. Suppose generally if I talk, if A is the acceleration of the body, m is the mass of the body, the force acting on the body is given by the equation F is equal to ma according to Newton's second law. But in this particular case, force of friction is equal to mg sin theta. That means because of mg sin theta only it slides down. So suppose if I take these equations 1 and 2, if you compare left side force only. If you equate the right hand sides, ma can be equated to mg sin theta. M is common. So a is equal to g sin theta. So simply you are getting acceleration of your body sliding down on a smooth inclined plane, you get a is equal to g sin theta. But whereas moving up or projected up in the smooth inclined plane, what you will get? Simply A is equal to, you will write minus g sin theta, because since it experiences retardation, when time goes on increasing, the velocity goes on decreasing, because when it moves upwards, the velocity goes on decreasing to move upward. So it is called retardation. So we are putting the negative symbol and writing the expression. So simply we are following the same method for the acceleration of your body sliding down smooth inclined plane. We are following the same method for moving up projected up also. Finally you have to add the one word, since it experiences retardation, that means negative acceleration. The acceleration can be written by, since it is negative, we are putting negative symbol, A is equal to minus g sin theta. So it is the expression for not acceleration, retardation of the body moving up or projected up in the smooth inclined plane. The next part is, just we will change here, next part, rough inclined plane. rough inclined plane. For rough inclined plane, the frictional force is taken into account. The frictional force is taken into account. So how we can derive? Sliding down in a rough inclined plane, moving up or projected in rough inclined plane. How it becomes? Rough means the inclined plane is rough, so frictional force is taken into account. Suppose frictional force Fs, mg sin theta is the downward force, okay. To slide down, what happens? To overcome the frictional force, the mg sin theta should be more. The mg sin theta should be more. So what is the net downward force for sliding down, for coming down in the inclined plane? For example, I will tell you, if mg sin theta is 10 Newton, Fs is 10 Newton, it will be in equilibrium position because 10, 10, they are balancing. Suppose if mg sin theta 1 Newton increases, that means 11 Newton. 1 Newton increases, that means 11 Newton. Frictional force is 10 Newton. So 11 Newton minus 10 Newton, how much? 1 Newton. That 1 Newton is the net force for the downward action. So what is the net force? What is the net force which acts in the downward direction? To slide down, which acts in the downward direction. What is the net force? mg sin theta minus Fs is the net force. Net force which acts in the opposite direction. So this is the main equation you have to form. Sir, what do you mean by Fs? Here you should not write Fs because it is moving. So Fs should be replaced by Fk. Moving, since it is moving, you should mention kinetic friction, not static. It is sliding down, moving, so kinetic friction, not Fs. So what do you mean by Fk? You know, from the coefficient of friction, mu k is equal to Fk by R. So Fk is equal to mu k into R. But from the diagram, R is balanced by mg cos theta. R is balanced by mg cos theta. So if you substitute the R value here, Fk is equal to mu k into mg cos theta. So this value you have to substitute here. You have to substitute here. So the net force mg sin theta minus mu k into mg cos theta. This is the net force. So already in the previous case we have seen, if A is the acceleration of the body, m is the mass of the body, then if a force acting on the body is ma. So if you equate this equation 1, this equation 2 means, if you equate these two forces, ma should be balanced by mg sin theta minus mu k into mg cos theta. Here m is common. Then mg sin theta minus mu k into mg is common. In both the cases mg is common. So you take mg is common. mg sin theta minus mu k into cos theta. Here ma. In the equation, m is common, mass is common. So A is equal to g sin theta minus mu k into cos theta. This is the expression for acceleration of your body sliding down on a rough inclined plane. Here, the frictional force is taken into account. When it is sliding down, we are subtracting mg sin theta minus frictional force, Fk. Suppose when it is moving up, projected up, what happens? If the block should move in the upward direction, what you need? In addition to frictional force, the mg sin theta should be added to this equation. That is the net force. Net force which acts in the upward direction to move upward. What happens? mg sin theta plus Fk in the next case. So it becomes plus. All other items are same. It becomes plus. It becomes plus. It becomes plus. So it is the retardation of the body. It is called retardation. The last expression is called retardation. So when you talk about acceleration of the body, projected up, moving up in the rough inclined plane means A is equal to, you have to put minus symbol, then G sin theta plus mu k cos theta. You have to write like this. For the moving up, you have to write this like this. For sliding down, already we have seen. Just by changing the symbol, we are deriving it. So totally, you know how to find out the expression for acceleration of your body: sliding down, smooth inclined plane, moving up in the smooth inclined plane. The same way, sliding down in rough inclined plane, moving up in the rough inclined plane. So 4 parts we have covered. Thank you.